Welcome back. In this video, we're going to factor quadratic expressions using a combination of common factoring and our technique for factoring trinomials that look like this, where the coefficient of x squared is not 1. Let's jump right into an example and factor 24x squared minus 52x plus 20. No matter what expression we're trying to factor, we should always try to common factor first. Since our values of 24, 52, and 20 here are all even numbers, we could common factor out a 2, but we can do even better. The greatest common factor of these values is actually 4, so let's common factor out a 4. 4 times 6x squared gives us our original 24x squared. 4 times negative 13x gives us the negative 52x term of the original trinomial. And 4 times 5 gives us the 20. Now let's take a look at the trinomial that we have in the brackets. Since the coefficient of x squared here is not 1, we start factoring this expression by finding two numbers that multiply to 6, say 3 and 2, and two numbers that multiply to 5. The only option for that is 5 and 1. When we check the so-called cross products of these values, we see that they total 13. But our coefficient of x is negative 13. No problem. Making both the 5 and the 1 negative doesn't change the fact that these numbers multiply to positive 5, but now we get our desired sum of negative 13 from the cross products. We now have everything we need to finish the factoring. Remembering to write our common factor of 4, we can then rewrite 6x squared minus 13x plus 5 as 3x minus 5 times 2x minus 1. And that's it, we're done. Let's finish with one more quick example. Let's factor negative 12x squared minus 3x plus 15. As always, we check to see if we can common factor. And we can. The greatest common factor of 12, 3, and 15 is 3, but since the coefficient of x squared is negative, we'll factor out a negative 3. To get our original trinomial of negative 12x squared minus 3x plus 15, we would multiply our common factor of negative 3 by 4x squared, 1x, and negative 5. Once again, our common factored expression contains a trinomial in which the coefficient of x squared is not 1. We start by finding two numbers that multiply to 4, perhaps 2 and 2, and two numbers that multiply to 5, keeping in the back of our mind that we're actually working with negative 5 here. Again, our only option is 5 and 1. Unfortunately, even if one of our cross products was negative, they would not add to the coefficient of x, which is 1. And switching the positions of the 5 and 1 doesn't help. Instead of using 2 and 2 to multiply to 4, let's try 4 and 1. Now our cross products are 4 and 5, and if this 4 was negative, we'd get our desired sum of 1. Furthermore, we know that either the 5 or the 1 here must be negative to multiply to negative 5. So we make the 1 negative, which then gives us the negative 4 we want for the cross product. Finally, we write out our fully factored expression, which is negative 3 times 4x plus 5 times 1x minus 1. For lots of interactive practice exercises on factoring expressions like the ones in this video, check out the link in the video's description.